So, Gashon,
Yes.
how should we start, do you think?
Let's say there's two of them.
Yep.
One here, one here. Right. And with the tie,
All right, now you should see what I'm kind of 7 different segment pins. Yep.
and then once it
Oh, nice.
goes
That'll work, because you all want them to be zeros, so why not?
Yeah, I know. Okay, so like I was gonna have this as my zero. So one of them you're using clear, one of them you're using right? Right, and then
Uh-huh.
so you just tie to a switch and just leave the switch.
And then, yeah, you can just copy that whole thing, and then just take out your switches on the next one, and instead of using the
Instead of going to clear, instead of
oh,
going to
because
clear,
you're using the load.
oh crap, yeah. So this is not right, right?
No, that was right. You have something coming out of the load, right?
Well, no, we're loading 0, right?
Well,
You're gonna load
so what do we...
But do you see your enabler?
So we know we're going to need...
4-bit counter.
Yeah, we're definitely going to need those. So, where do we get them from?
So a quarter thing.
Yeah.
This one should use the label, right?
So we're... In the past when we've gotten components, how did we get them onto the page?
Right? Should we use the enabler?
Using the AND gate thingy?
That's right.
The NAND game.
You have your load set up.
We are looking for...
So we're not gonna need to open our thing again, right? So this is a complete new
We
thing?
don't because it's right there already. So are we going to need that component?
Okay.
As long as we're here, we should drop it in.
Yeah,
On the next one, we're going to want to use.
that's the actual 7-segment component.
Yeah. We're going to need, 2 of them. Awesome. Yeah.
Guys, using this computer over here?
Don't work.
Yeah, sorry.
No,
And what else do we need?
we've tried it a few times.
Alright.
Power turns on.
Yeah, go ahead and try to log in.
74161 4-bit counter.
Yeah, so I found in the parts library, others max plus 2. It's in others max plus 2.
Oh, okay.
Max plus 2.
Either way it'll work.
74161.
One that's loaded, one that clears at 12. One that loads at 12 goes there. One that...
That looks like it.
Yeah.
That's why it's
2 of them?
Okay. Can I take this one out?
One more 12 counter design. Synchronous load input. So to do
And I think what you're doing right now is the second one.
So I've designed the counters already, but the way I drew the picture is a little different than the way they appear on the screen. So we're going to have to figure out how to connect them up in Quartus in a way that matches up with this design. I'm assuming you guys trust the design.
I mean, I didn't even do any prep, so...
Okay, well, so we're going to follow this, and we're going to test it and see if my design works.
4161, so this is a... Inverted 3-bit
Yeah.
4.
No, I want to do low.
But I thought you didn't. I thought you don't need A through D to be tied to anything when you're clearing.
Yeah,
but you
I'm
do
doing
when
the
it's
load
loaded.
one right now.
But you actually. Oh, and I see, and it's tied to. Okay. So when you do this for a clear, then you won't have this tied to high. Or you'll tie it to.
And we're currently working on the load design.
I don't know. Which one are we working on, Sean?
NAND gate.
Load design.
We're doing the top one.
Okay, load design.
So this is the synchronous counter.
The synchronous counter. All right.
Not quite. It's got a bubble, so that's a NAND.
Oh, I thought it was just gonna be an inverted and I was gonna put an inverter with it.
Yeah, because I know they clock enable, so it has to. It's a clock enable, and then there's
I think you have to hit escape.
Yeah.
There you go.
Now there's a program called VCC. Is that just tied to high? Well, you would assume, right? Yeah.
that should just be,
All right.
All right. Try her out.
Where do you get a clock from?
Sorry, say it again?
Where do you get a clock? Oh, no, you don't have that.
Yeah, so the clock is going to be connected to a push button switch. We'll talk about that when we get there.
Okay.
This one's a two input.
I would one of these days like to get, I mean, if we just run this and go on these
See if it works on your own.
I would like to make it functional.
2 input NAND goes on the asynchronous counter.
I'm still confused by this, but I think that's just correct. Yeah.
Because I may be getting this completely wrong, so if I say anything else, I can just wrong.
Oh, yeah, that's, we've already defined the cyclone to blah, blah, blah. It's already defined. No, we don't put it in the already established. We could, for example.
You're telling me I can put it in on
That was already pulled.
Good. Yeah.
Our
Okay.
USB flash?
Oh, no, just by selecting. Start? Yeah. Negative logic.
Negative? It's supposed to be
The
0?
inverters in there. Hold on a second, though, before we start. Let's run through this. I get the other sheet of paper.
We're just gonna hold it there. Let's get together.
What's your punch button here?
So the enables need to be turned on.
Because our shield
Something that might help to zoom in.
Yeah, maybe we should zoom in for sure.
is the entire counter.
Michelle?
I think it was just the jog wheel.
Can you so you hold if you hold control and move the wheel forward, yeah, there, or do that. That works. Might make it a little easier to aim.
We're going to call it 1.
Oh.
2. 4.
Oh.
5. 6.
And then,
8, which all of them are 11, none of them are 11.
cycle through the 7.
So that's 0.
Oh, we haven't enabled it.
Oh, we'll just leave it where 1, because it's going to be under the.
Yeah, that's the one. That one's not. Yeah,
So
Later on,
what do I have this for two?
yeah, it's just blank. It doesn't connect to anything.
Wait. So what you do is A, right?
Yeah. And I knew that because I looked up the data sheet for this part.
Okay.
Where were you able to find that data sheet at, Max?
I googled 74161 counter and hit the first link, and it took me to the data sheet. It's the time-honored method for finding data sheets.
Google.
Google. Yeah.
No Ash Jeeves? I mean, who actually uses Ash Jeeves anymore?
Yeah, right. Are you from the 90s?
I know, right? Break out my slap bracelets and my fun dip.
Nice.
if there's a line going over it, I don't think that it's, I think I'm so when I started,
I don't know if you're supposed to do it.
It works, it's just gonna make it work.
I'm assuming
Right, I think that works. It doesn't look like a good, right? It's not giving us any X's or anything.
No.
Let's hope not.
There you go.
There,
yeah,
yeah.
that's better though.
Perfect.
That is nice.
Fucking perfect.
Okay.
Okay.
Now,
All these connect them together?
yes. Well,
All
A, B,
tied
C,
to-
and D. Yeah. And they will be tied to the ground. Yeah.
I just pinned the clock in the other one.
Yeah, they look pretty tied together to me.
Where do I get ground from?
I'm not sure, but I'm guessing you click on the NAND gain. Not that one. The one that we used to, the components button. There we go.
Good. Is there any?
Guessing it's a. I would guess it's a primitive. You close the logic menu and we'll see what's there. Other? Might be other. Nice. There it is.
make a new thing, save it as that thing's name, and make save it as a bunch of names.
1 side, 9.
That's probably. Yeah.
good to me. All right. So we still need to connect a few more things to this counter, right? So what else do we need to connect to this counter?
Need a clock.
Yeah, we need to connect clock, right?
Oh, it's right there. So
Yeah.
I thought maybe it was something else.
Is it going to be a 1?
Well, we need to connect it to a switch. So the clock is going to be controlled by a push button switch on the board.
Okay.
So the first thing we're going to need to do is put a pin down, right? Do you remember how that works? Okay.
As an input.
It's an input.
Word.
Uh-huh. Cool. And let's name it.
Let me see. Load.
Well, what is it doing?
Clocking.
Yeah. So let's name it clock.
CLK.
I love it.
Shorthand. Sounds like click.
Or clock. Both. I'm happy with either of them.
Word.
Well, that's not the clock. That's the
Clear.
clear. Yeah. So I think you have to delete that one segment.
Does Control Z not work in this?
It does. You can. That works too. Yeah, let's get rid of that X. Cool. And then we also need to connect so we should really connect all of the inputs. So what do we do with the others? Oh, actually, it doesn't look like it. Okay, I don't think we need to connect anything to EMP, but we do need to connect to ENT.
ENT goes to.
ENT is going to go to one of the toggle switches. Yeah.
So ENT is also going to go to a switch? Or is it the only switch that we have?
There's going to be 2 switches, one push button and one toggle. And you're right, ENT is going to go to the other switch.
All right.
So yeah, Krishan's on it. That's nice.
Can we make those smaller?
Might be, yeah.
Yeah, I think so.
Beautiful.
Word.
Yeah. That's what we pulled out lab 2 to go. No.
Looks like you got it.
So what did you fix this afternoon? Because I couldn't make it.
Which one?
There was something you saw. He emailed us. He wanted us to fix.
Oh,
I
he
couldn't
did.
get it.
He got that already. It was.
Oh, okay.
Yeah.
But there's nothing from lab 2 that you needed.
Cool.
All right. I'm gonna
So-
stop record. Or okay, no, go ahead.
Okay, so we need some outputs, right?
The lab 3.
Yeah.
Because we need to be able to see this.
One
So
goes to the 7 segments.
And so our outputs are going to be.
So this one, of course, is built. It's going to be built on from lab 2, but you don't use any of the
I think it'll be easier to move the 7 segment to the other side. There you go.
I was like,
Simple way.
just try to follow these.
that's what I wanted to do, but then I
And
don't know
before we
this
just
thing
connect
from
the
remote.
A's to the A's and the B's to the B's and the C's to the C's, let me make sure that we're using the same.
Yeah, this is
So, oh yeah, so it's backwards. When we designed that 7 segment display, we designed D as the least. Well, I designed D as the least significant bit, but on this counter, A is the least significant bit. So we're gonna connect them. How are we gonna connect them?
D to A.
Yeah, yeah. So that's My bad, but
There's always a way around it.
yeah, well, we can handle it. How do we get here?
Oh, I clicked on it.
Oh yeah.
D to A, C to B.
And let's save real quick. Save all. Cool. Yeah, great. All right.
So D goes to A,
Yeah. Which A?
QA.
Yeah. Yep.
So 7-segment D is going to go to QA?
Yeah.
Okay.
Whoops.
Yeah, a little bit.
My bad, guys.
It's all good.
There's no C.
C's going to go
Oh,
to
there's no C or it's
C's going to go to B.
Yeah. So C's gonna go to B.
B will go to C.
Yeah. Agree?
and B to D.
B no.
B
or
to C.
Yeah. Not that C. Sorry.
No,
Control Z.
the QC.
Oh,
Yeah.
I thought I was C. It's not gonna be going to anything.
Well, it will be connected to an output.
Oh,
Sorry, it's
okay.
not doubled back on as an input, but it will connect to an output. Because we do care what
I
it
thought it was like an empty.
well, it isn't the
Useless
diagram I drew. But,
thing.
the diagram I drew is incomplete.
An A to D, QD.
A to
Yeah, QD.
Beautiful. Okay. And what else needs to happen?
Do those other outputs have to be attached to something as well?
They sure do.
So we need RBCD.
So what were they connected to in the last lab? The A, B's, C's, D's, all the segments. You remember?
I'm trying to remember. What were they connected to last lab?
Well, they were
Connected to pins?
They were connected to pins, yes, absolutely. So, let's do it again. How do we put pins?
Let's get the pins.
Beautiful. And are they input or output pins?
Output.
They are output pins. Cool.
You need how many? 4, 6, 7?
7. Yep. And let's name them. So here, I'll type. So you handle the clicking and I'll type. So A1. D1. Whatever. C1. D1. Cool. And why am I naming them 1, B1, or A1, B1, C1 instead of just A, B, C?
Well, gonna have more inputs.
Yeah. Well, we're gonna have more
More
outputs. We're gonna have
outputs, I
another.
mean.
Yep. So we're gonna have another. We're gonna do this twice at some point. We'll worry about it in a sec. I think we should get one working and test it on the board, because that will, if we've made any mistakes, then we'll know about it. Faster that way. Won't make the same mistake from the second lab, or the first lab, I guess that was.
These two, when you got them, they were DSF files. So I had to go back to zero. You started a project to add the files. I did this whole thing in but how did they
Okay, I just want to
Oh, yeah.
prettify this a little bit. Okay. That looks. I'm happy with that.
Alright.
So let's save. Beautiful. Okay. And now we need to do one more thing. What else do we need to do?
Is this where we compile and test? Or no, we have to add
One more
another
thing
output?
Well, we have all the outputs we need. We need to assign them to pins.
Okay,
Remember the
pin
pin
assigner.
assigner?
Okay, yes, I do remember that.
Yeah. Okay.
ENT clock is clock enable, it's ENT. Yeah, that's what I thought.
20 minutes and counting, gentlemen.
Oh. All right. Cool. Hey, that's good. We're going fast. Okay. Cool. Okay. So, do you remember how we assigned pins? Do you remember how we assigned pins?
Assignments. Assignments next to projects. Pin planner.
There it is. Cool.
Yeah, this Sudoku thing. All right.
So, which pins are we?
So,
Yeah, not there's
so
the
first,
question,
so
right?
should we start with inputs or outputs? What do you guys think?
Inputs, because we have less of those.
Yeah, I like it. Okay, so we have two inputs. One is the clock and one is the enable. Right?
Right?
Okay, so how did we get nodes to appear? Oh, I think we
We
first
typed
picked-
them into the location once we figured out where they were in the pin assignment.
So I'm gonna figure out where they are. So we're gonna connect enable to pin L22.
L22. Last one. Look at that. It's a clock signal.
Yeah. So how did you do it? I don't remember. Did you click on it?
What pin is that? I'm sorry?
L22?
No. What's the name of the output?
Oh.
Or the input? The
The input
input.
is gonna be enable.
Enable. Scroll down the node name. I think it should probably be in.
We have to add them, I think.
Yeah.
Yeah.
So the enable node?
Yeah. What do we call it? What did you call it? ENT?
Yeah, I think you did call it ENT.
Okay.
Capital E, yep. And then I just click on it.
You can type it into location as well. Where it says ENT, space, direction unknown. Yeah.
There.
So
One higher.
L22.
One more.
Higher.
Yeah, L22. There you go.
Cool. All right. Then we've got one more input, the push button switch. So
That was I forgot what we named it.
well, so we made a new node. Started by making a new node. How do we do that?
Input name of the node.
Yep. Here, I'm gonna write. What do we call it? Clock.
Mark, it works.
Yeah.
Cool. So we enable I just started it.
What was that message? Can't create node, new node.
You can't make a node with the name new node.
Oh, makes sense.
Yeah. Okay. There we go. And then this one we're gonna connect to. I've got push button switches. R22, I think. Boom. Okay.
R22.
And outputs.
I saw that. Yeah, I mean, it just worked. Okay.
I think that was the whole.
We just got a pretty significant bit with this enabled.
So how do we put in the outputs?
Same way.
Same way. Yeah, I like it.
Should we go back to assignments again?
So we'll probably start with A underscores, or do we have Qs or anything? Q outputs.
Yeah, it's just gonna be the things. So if you minimize this window real quick. So the same way we connected the inputs to those, we're going to connect the outputs to these.
Okay.
That little symbol means you're going to connect a pin to it.
Okay, so we're going to look for A1 outputs, right?
That's right.
Cool.
Yeah, and see, you can see our pins are there. Woohoo! So that's good. That means it's working. All right. So let's go back to the pin planner.
The pin assignment.
Go bring it back up.
I think it's in the Quartus one. One over. Yeah.
Cool.
Now look at that code and.
All right. So
That computer wasn't logging in for us.
they fixed it.
Yeah.
No, I'm serious.
Well, it's not our problem. Okay. So we're gonna need a new node. Awesome. A1. And Okay, and
Oh, success.
connect it to
I don't know.
J2, I think.
Maybe I had a wrong character in there.
Are we supposed to just tie them all together?
Actually, you know what? I think I can just run this. A2. And
Okay,
can you
yeah.
just no clicking for a second? Yeah.
I don't know how to.
If you can read off those names, so nice and fast. Pin J2 is the first one.
So,
Oh, sorry, not
wait,
A2.
wait.
P1. Sorry, there we go.
Remember you said this thing is reversed on MSB? MSB? Oh,
Well, it won't matter with the segments. Okay. So, actually, you know what? I'm going to do this differently. A1, B1, C1, D1. There we go. This is smarter. Okay. Yeah, because we're talking about the segments, which don't have significance. They're just labeled. Okay. So
where did we get R22?
that was for
Pin J1.
We got that from.
Pin J1 is B.
Okay.
Right here.
Okay. I was just wondering where the R22.
Yeah.
Oh, yeah, I remember now.
For the columns and the rows.
Input, okay.
So next one.
Okay, C1 is H2.
C1. Like that.
No. It was H2.
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 Next one is F2. F1
F1.
and E2.
A2.
E. An egg. Yep. Oh, what that means?
So you attached it right there.
J2, J1. Oh, this was supposed to be H1, then H2.
H2. H1.
No. After J1, you go to H2, yeah?
Yeah.
After H2, you go to H1.
Oh. H1. Okay.
Then F2. F1. And E2.
Cool. Looks good to me. All right. Close the pin assigner because I think that's everything. Roll over here. Oh yeah.
Pins are showing up.
Nice.
Now we're cooking with Crisco.
Yes. That's awesome. I don't know if it'll compile with those suckers. Well,
Just takes forever to compile.
why did it switch? Oh dear. Do not know. Oh dear. So the problem we're having is it right now thinks that 7 segment is the top level file.
Okay.
That's not what we want. So we're trying to add file. Oh wait, here we go.
Alright, let's read this because
Yeah, that's not good. Yes,
in this case, or put the seed of the source. Clear. You must name the node.
So right here.
That's why
I don't think this is the same as connecting.
there it is. I don't know if that's right. There we go. That's what we want. Okay.
is this right?
Set as top level entity. Awesome. That's exactly what we want.
Maybe we don't even need it.
Alright.
I'm feeling that you have to.
Save all.
Is this your most significant bit or just QC? No, I meant like this chip. Is this chip?
Alright. Let's set this guy up.
Is it really what did it say?
Guy. I haven't done this, so I'm
Yeah.
not doing this.
There's a tool specifically for the box.
So did you figure out what was wrong with the last line? Like,
Yeah, so the problem was
yeah.
when you edit
Yeah.
a BDF file, it doesn't automatically change what's in the component. So you know how you go Remember I showed you after class?
Yeah.
Yeah. So that was the big.
Yeah, there was
problem.
something else you told me this morning that we needed to work on, but I couldn't make it.
Oh,
It
that.
took us some time.
The problem was we hadn't made this basically.
Oh, I see.
We were supposed to turn it into one of these.
Yeah,
Oh,
We hadn't
okay.
done it.
So
I lost our that one, and I didn't know if we needed it, so I redid the whole thing.
And power, because apparently USB power is not good enough. All right, so let's program it. Wait, first let's make sure it's set to run. It is set to run? Somebody else check. Cool, all right. All right,
Is it
so
supposed to be run or program?
it's supposed to be run. If it programs, it'll program permanently, and then the professor will come mad at us.
Screwed.
So we're not going to do that. So we need to program it now. I mean, program it in run mode. So how do we program device? Do you recall?
See, I think it sees this as all.
Yeah.
Task, compilation,
Nice. Thank you, Snake.
indeed.
Because lowercase b, and then it does capital C. Well, he's got it. No worries.
Rochelle? So, that mine. Are you stealing my stuff?
Oh my God, this looks just like mine.
That's weird. Okay, so, well, so Snake remembers. So you can just ask Snake.
Okay.
Or you can look it up, I guess.
Hell yeah.
Now
31 minutes and counting, gentlemen.
Hey, not bad. If it works, we're halfway done. Assuming it works.
I think we're going pretty good.
Yeah.
what?